Hello all. Yeah, let's move into problem number 26 now. Let's read out the problem. This problem says about a reciprocal cycle. You see there are certain fractions. For example, 1 by 3. You'll see the 0.3333 like that going on. That 3 is repeating. When that number is repeating or the sequence is repeating, there is this bracket included. So just like that, if you look at that, 1 by 7 is 0.142857, and these numbers 142857 will be repeating. So the question is asking that if we continue to do that, where d is equal to 2 to 1000 up to 1 by 999. Okay, we'll start with 2, go on 999 and find out which number, that means 1 divided by which number, gives us the maximum length of this sequence. In this case, the length of this sequence is 6. We'll have to find out. We'll just take one example. Let's take the example as 1 by 7. You see in 1 by 7, it says 0.142857. Then 142857 is repeating. Now, if we ask that, okay, how can I create this repeatable number? Instead of dividing it, let's say I try to create a list, and that list will contain the numbers like this, numbers like 1, 4, 2, 8, 5 and 7, etc. So I want to create this list. Okay, how can I do it? First of all, you see the first one point is 0, and how can I get this 0? I'll just do an integer division of this number. So I get 0. Okay, now instead of integer division, if I do it like modular division, that means I want to find out the remainder of it. The remainder is 10. Remainder is 1. Okay, now what I'll do, if I multiply that 1 with 10, which becomes 10. Now if I want to again divide, integer divide by 7, what happens is 1. And you see this one is actually this one. Now again, if I want to do so we got one number. Let's say I'll just keep it. We got one number 1. Now I'll multiply that remainder with 10. So that becomes 10. Then I do integer division again. So if I do a modular division again, then I get 3. Okay. And that 3, that means if I again multiply that 3 with 10, multiply it by 10, that becomes 30. Then if I do integer division of that 30, that becomes 4. So that's our next number, 4. So I got 4 here. Now what I'll do, instead of that, I'll just do a modular division. That means I'll just try to find out the remainder of it. So now I get 2. Okay, and by repeating this process, what I'll do, I'll just again multiply it by 10 and then divide it by integer divided by 7. So I get 2. That is our next number. I get 2, and I'll repeat this process. So what I'll do, instead of that, I'll just make it the modular division. So I get 6. Okay, and then what I'll do, I'll again multiply this by 10 and modular division by 7. That becomes 8. So that's our next number, 8. So this is how we can basically continue doing it. But once in a while, we'll see that this number is repeating. Okay, let's continue this process. So what I'll do, I'll again modular division it by 7. Then I get 4. Then I multiply it by 10. I get 40 divided by integer division 7. I get 5. So our next number is 5. Okay. And to continue the process, I'll make it this. Then I'll multiply it by 10. Actually, I don't need this bracket. But okay, let's keep doing it. So, and then I'll do integer division by 7. So that becomes 7. So our next number is 7. Okay, next what I'll do, I'll make it a modular division. I get 1, then I multiply it by 10 and integer division by 7, then I get 1. That means our next number is 1. And this one, and if I keep doing it, then next number I'll get 4. So this one basically, it's an indication that our cycle is repeating. So that means in our search, when I find a number which is already existing in our list, then our search should stop here. That means we found our repetition, and that's what we are looking for. Once we find our repetitions, our search should end there. So let's try to create a program to implement this. So I'll just create a function. My function is this: def, I'll say get list of denominator. Okay, I'll just keep it like this, list of denominator. So let's say I take a number as n, and this will be our list which will return. Then we'll see number is equal to 1, because that's why our initial number is 1. Now okay, now we'll keep track. In order to keep it, I'll just create a set, okay, because I don't want to repeat all the elements. It may not record. Let's see. While true, I'll create an unconditional loop. I'll just create a divide. Div is equal to, that is our number, which is 1 initially, modular division of n. And then I'll just change our number is as number modular division of n. And then I'll just append, list.append is div. Then what I'll do, I'll just say if number equal to 0. If number is equal to 0, that means we got the full number. Okay, that means it's our fraction search is end here. Number division 0 means, for example, if I try 1 by 2, and you see it's just 0.2, and so when we divide by 5 with 10, then we get exactly 5 numbers. Okay, so that's where our modular division will give us 0. That's why this condition is there. If number is equal to 0, or I'll say number in num set. Actually, we don't need it, I believe. Number in list. If I just do number in list, that should be enough. Or number in list. Okay, that's our second condition. That means if the number is already there in the list, we'll end our search break. And what we'll do next, because this number is our remainder, so we'll have to multiply it by 10. Number is equal to number multiplied by 10. And what we want to return? We want to return the list. Okay, so let's see if this is working. I'm not using this, so I don't need it. Let's check it. Get list of denominator. So I'll just try with 7. Okay, I see, because this number, we're just adding division, but we also have to add this number. Yeah, this one looks correct. Okay, let's have a look at what is the number set here. Okay, so we need two tracker, because number set is keep tracking the remainder. Okay, for example, the number is equal to number remainder of n, and that remainder is being added in number set, whereas in our list we're adding just the integer division, the value of integer division. So the content of list is our answer, but the set contains the remainder. We need both of it. Okay, so you see, that's our answer. However, if you really want to know the repeatable part of it, the repeatable part will be, this 0 will always come. So I can remove this part. Okay, so if I just change it, so this is the part that's repeating. Okay, let's do our search. Let's say maximum value is 0, and the index positions will start with 2 to 1000 and find out which index is giving us the maximum. So I'll just keep track another as maximum index is equal to 0. Okay, now what I'll do, I'll just get a for I in range 2 to 1000. I'll just get value is equal to length, because we are interested of length. Okay, so if I just do length of this 6. So the repeatable cycle for 7, 1 by 7 is 6. Similarly, you can do it like this. For example, 11 is 2, something like that. Okay, so we are interested for the length. So length, I'll say get list of denominator, and the value I gave as I. Now we'll have to track for the maximum. Okay, if the value greater than max, then we'll make max as value, and then similarly we'll just keep the max index. Max index is equal to I. Okay, so if I just run this loop, and let's see what is our answer. So if we check a max now, max is 982, and what is the index? IDX, that's 983. That means the answer to our question is 1 by 983. Okay, 1 by 983. So this will be our answer, but anyway, this is not, the cycle will continue, and if we really want to know the cycle, that will be like that. Okay, if we just keep it, then keep 983, this is our answer. This whole thing is the cycle. Okay, so now let's see if our answer is correct. Max IDX 983 is our answer. 983. Yeah, our answer is correct. I think that's it for the current lesson. Thanks for watching. If you like my video, please share and subscribe. Thanks again.